Okay, so now we're here on the board and we're going to figure out what the velocity of the sun needs to be in order for it to not drift around. So let's draw a coordinate system first so that we can locate ourselves. So up here I'm going to have this be the x direction and up and down be the y direction. And we remember how we had our setup of our planet and the sun. So our sun is right here and our planet starts around here. So we know that the planet has a velocity in the x direction and a velocity in the y direction, and so does the sun. Vy, I'm going to put apostrophe s for the sun, apostrophe, or not apostrophe, comma, p for the planet. So we know that the sun and the planet are both orbiting, they're both gravitationally bound together. So if the planet moves somewhere, the sun is going to move with it. And we saw that in the previous steps. So initially, our planet moves up with some velocity in the y direction. And we want to figure out what the velocity of the sun is so that it doesn't follow the planet. So in order to do this, we're going to use conservation of momentum. And pretty much what we want to say is that the addition of both the planet's mass times their velocity is going to equal 0, so that the sun doesn't drift along with the planet. So let's look at the velocity. Let's look at momentum in the x direction. So we're going to see that momentum's given by the letter P. Momentum total in the x direction, we want this to equal 0. So in order to do that, we can write out the mass of the planet times the velocity of the planet in the x direction plus the mass of the sun times the velocity of the sun in the x direction. So the velocity of the planet in the x direction, we know, given in the code, is 0. So this is going to be 0. And the only way for our whole equation to be 0 is if the velocity of the sun in the x direction is also 0. So now we know that, well, this was given, right? Velocity in the x direction is 0, and velocity of the sun in the x direction is also 0. So this just means that the sun isn't going to move left and right. Now we want to figure out the velocity of the sun and the planet in the y direction. So we're going to do something, or we're going to do the same thing. So momentum total, again, in the y direction. We want this to equal 0, and we're going to write the same thing above, just for the y direction. So this is going to be the mass of the planet times the velocity of the planet in the y direction plus the mass of the sun times the velocity of the sun in the y direction. And since we have an equation that's equal to 0, we can just move things around in order to solve for velocity of the sun in the y direction. So what I'm going to do is on either side, I'm going to subtract mass of the planet times the velocity of the planet in the y direction. And on this side, right in here, I'm also going to subtract mass of the planet times velocity of the planet in the y direction, such that I get minus m planet, v planet in the y direction is going to equal mass of the sun times the velocity of the sun in the y direction. So now we have this equation. Because these two canceled out, a positive and the negative, the same negative canceled out. So we're left with this. Now, since again we want to solve for just the velocity of the sun, we're going to divide each side by the mass of the sun. And here this is going to cancel out the mass of the sun on my right. And I'm going to be left with the negative mass of the planet times the velocity of the planet in the y direction divided by the mass of the sun is going to equal the velocity of the sun in the y direction. Cool, so now we figured out that the velocity of the sun in the y direction first has to be going in the negative direction, and all we have to do is multiply these values. And these values are the mass of the planet. If we look back in our code, we see that it's 0.2. And the velocity of the planet in the y direction is 28.87. And we're going to divide this by the mass of the sun, which is 1. And this is going to give us velocity of the sun in the y direction. So if we put this in our calculator, we can quickly find out that this is actually going to equal negative 5.77. So let's try this value and see if our sun drifts around in our code. Okay, so we just figured out on the board that the velocity that in the y direction that our sun has to have is about 5.77, or is 5.77. So let's put that number in our code and see if it helps. So instead of -6, we're going to put 5.77, and we're going to click play and see what happens. So as you can see, it starts out, it's going from 0 to like 1, back to -0.3 or something. But as the planet keeps orbiting around the sun, our average velocity of the sun is getting closer to be around 0. So it's oscillating between like 0.1 and -0.1. 0.1, -0.1. So that just tells us that our sun is being tugged on by the planet, but it's pretty much staying in that same position throughout the whole orbit of the planet.